My name is Anthony Ekpechue. I'm a cloud consultant with Global Logic. And today my talk is about zero trust. Anyone know anything about zero trust? Yeah. A little bit, okay. And you, sir? Yeah. All right. So zero trust is the hype and the buzz is getting more and more everywhere these days. People talk about zero trust. But what does it mean? And how do you apply it to your environment? So what we're going to look at is in this serverless environment, okay? A lot of companies would have servers behind a firewall, and that's great because you've got everything settled, right? But in the serverless environment where everything is either on the cloud or your runtime is being housed by someone else. So how do you ensure your system is completely protected? So the agenda is quite few. I don't want to spend so much time. So the pillars of zero trust. So if zero trust, there are a bunch of pillars. We'll go through those. And then why serverless? And then we'll go through a case study for an application I was working on. Quite interesting. It's called Zelda Online, anyway. So the pillars of zero trust are quite simple. The whole point of zero trust is do not trust anything. It's just simple as it is. Don't trust anything. Always verify. And then explicitly, and even if you do verify, do not make any pre-assumptions because point A is trusted, then I must trust point B. So you got to verify everything. And then the other pillars here are least privilege, fine-grained permission, assumed breach. So assumed breach is you preempt breach. So a lot of people tell you zero trust is reactive. No, it's not. It's actually preemptive. It's proactive. You assume. So we're going to go through something that I've been working on as well. But the point is, assume that every point in your architecture that there is a breach. So that sort of changes your mindset, right? So more or less is a paradigm shift, the mindset shift in the company, right? So then the other part of it is micro-segmentation. And then the big part is continuous monitoring. So we'll look at all that. Now, why serverless? Again, it's quite easy. Serverless is easier to maintain, cost-efficient, auto-scaling, all that nice stuff. I look at serverless as handing over my problem to someone else, all right? Because then I can hold them responsible for failure and SLAs. So it's quite easy. But these are the few things. Now we've got this application. It's an e-commerce application. It's quite unique because a lot of companies would say, you know what, I can't protect an e-commerce because it's public facing. But then what's the point of zero trust if you can't provide safety for your e-commerce application, which is where a lot of breaches happens, right? So for that application, we did something. It was a wireframe. And that wireframe just ensures, and now I must say, we used AWS in this case anyway. So it could be Azure as well, but one of the reasons why AWS came quite recommended is because it's got static S3 bucket. So what we're building an e-commerce on an S3 bucket using that static website. So that's quite easy. So you don't actually need to worry so much about building your website, just hand it over to AWS and then do a few things there, and then it gives you. So looking at the architecture there, do you notice anything interesting about it? This looks like something you do every day if you're an SRE engineer. Yeah? Bucket, event bridge, RDS transaction, anomaly detection. But there's something quite unique about this, and I'll tell you about it in a minute. Here is the end-to-end design, all right? And then in the end-to-end design, what we look at is static S3 website, like I said earlier on. And then we have security. So we've got two layers of vectors, and those vectors can be human or attack vectors. One is the vectors that you know, and that's guys coming in from your website, CloudFront, whatever, WAF. And then the other guy is a guy who's trying to an imposter. He's trying to go through some system to be able to leverage your advantage of security within your organization. But what we've done is we've looked at if you come through that certain route, there is no way you can bypass security because we have an end-to-end zero trust. So just making sure that you understand the schematics of this is a route comes through, you got CloudFront, CloudFront WAF behind it. So you could have a WAF, CloudFront, WAF, API gateway. The question is, can you actually overuse WAF? Anyone? Can you overuse WAF? No. Because the thing is, WAF is just a rule, right? It's got an echo behind a certain proxy. That's what it is, really. So you can't have WAF, too many WAFs, because you set up rules. That's what it does. It does at the back. So then we have Cognito. Again, Cognito is essential because what it does is identity, right? So the whole core of zero trust is, and I've had this discussion with a lot of people, with a lot of companies doing zero trust. They've said to me, zero trust is about blocking, providing perimeter access, moving your edge location to your infrastructure. But actually, that is not true. So what zero trust is, how do you manage identity? All right. So in that case, because identity provides you two things. It provides you authentication and authorization, right? Because authentication is who has access, and authorization, why. So if you can actually manage those two things, why means what access do you have? Why do you need access to a resource? So identity becomes the key part of it. Now, as part of that as well, you've got your anomaly detection here with SageMaker. Yep. And then we have Security Hub, Guard Duty, and all that nice stuff, which provides for your log aggregation, and then you use your log to cycle. So the whole point of that is continuous monitoring and anomaly detection. So if I see something with IP coming from a unique geolocation, I can easily go in, yes, I know where it's coming from, and I can mitigate that as well. So yeah, going down a little bit. Just before I go on, any questions? Yeah. Yeah, I'll go into it a little bit. And that's a good question, because what it does is, like I said, the first thing is paradigm shift. And paradigm is culture, right? Because the organization need to understand, the first thing is, do not make any assumption. Preempt breach. So preempt breach means you're looking at the way you set up your rules and what govern those rules. They are guardrails, policy definitions within your organization that actually sits a layer above whatever, whether it be HDLC or your infrastructure. So yeah, that's a good question, but we'll go through it. Now, this one is a quite unique design architecture. Now, the reason is, a lot of companies will come through here and say, we can block your API, okay? So internal access. You've got tools, Miriam here, OpenZT, Zscaler. I don't know if anyone has used those tools. And then you've got a lot of other stuff behind the scene. But that's good. But what about the public access? If you're a partner, partners have partner portals, right? And those partner portals can be exposed externally. So how do you actually protect that? Like I said earlier on, the core bone of everything is identity. All right? Identity becomes the only single source of truth in zero trust. And why is that? Why is that? Because there are several ways you can manage identity. You can create identity with Lambda Authorizer. If you're on AWS, it's still identity, Cognito, Okta, and all that stuff, because that's the only way you can verify a user, a device within your environment. And then if you've got that, everything else just fits in. So you could layer a VPN on top of it, or layer a pass-through definition with a proxy, but it's still behind the scene. Identity becomes what? Becomes a new perimeter. So I don't know if you've heard about this mantra. Identity is the new perimeter, okay? So anyone knows what that means? No. So identity is the new perimeter. If I go back a little bit, just one step, you could see that here we've got OpenID with Alt-N and Alt-Z. Alt-N is authentication, and then Alt-Z is authorization. So what that means is, within the public space, I can actually have my infrastructure sitting on AWS cloud, for example. And then I've got a hybrid cloud with on-premises access and everything. I can federate those identity. And then in the same space, I can have the single sign-on between the external identity and the identity on-prem. And what that means is if I've got an API, and those API, I've got users coming in from public space, I can actually segment my network in such a way that only users coming from public space will go through the public endpoint. All right? And then in that public endpoint, I still need to verify those users. Now, in an e-commerce website, you will say, but it is public. Yes, that's public. Yeah, but that's true. But the thing is that if you design your infrastructure or your architecture in such a way that you have an identity, like what we've done here, you have two types of roles. We have one is unauthenticated roles, and that actually give you users, unauthenticated users, public access. And then when you go to some transactions or infrastructure devices that you need protected. So let's say, for example, you've got a shopping cart, and then you set up your website, and everyone has full access to the website, right? We're going to make purchases and everything. They drop stuff to cart. You can set unauthenticated users to be able to do all that stuff. Whereas they've got authenticated roles where if you put stuff in a cart, before you get to the payment process, you then be challenged to set up an account. And then when you set up an account, what it does at the back end is it goes through Cognito or Okta or OpenID, and then sets up a JWT token for you. So this JWT token is then managed by guardrails. So the guardrails will be like policy definition, we'll go through all that stuff. And then it gives the company or the SRE engineers access to be able to say, I know actually this user is coming from Asia or EU West 1 or US, and then you'd be able to define boundaries based on those geo-segmentation, right? So that way, it's easier for you to then say, if I've got breach or an attack, I can actually segment those attacks based on geo-division. Do you know what I mean? On the other side of it as well, I don't know if anyone here know anything about a product called SPIFFE or SPIFFE. SPIFFE is a secure production identity framework for everyone. So what SPIFFE does is it's still an identity, but it's a workload identity. So workload for your Kubernetes or your containers, right? So you containerize the environment. And then why would you actually need a containerized environment if you have an S3 bucket? The point is there are transactions that you could still have on your Kubernetes clusters, right? That you don't actually want exposed to anyone else. So you have those transactions sitting in an enclosed NATed gateway or NATed endpoint. So what you can then do is, say, for example, you've got those transactions on Kubernetes, and then you still have your workload. You have some identity of workload on your on-premise. You can have a direct link between your workload on-premise and your workload in the cloud talk to each other using identity. There is what is called SPIFFE ID. SPIFFE ID gets generated as well. It's an authentication and an authorization device, which gives each workload an identity. So the workload in A would talk to workload in B without actually having any firewall or device between it. So it just gives you a break in perimeter to be able to access workloads across multiple environments. And the other thing here is OpenZT. OpenZT, I don't know, those actually are frameworks and open source solutions that provide you VPN. So in a case where you have private API endpoints, so those API endpoints, because you don't want anyone else to have access to it, you can then put a VPN, okay? It's like a software VPN in front of it. And that protects your environment. So you can have one layer of protection on the public, and then you have another layer of protection behind as well. So let's go through. So as I said, we talked about identity as a new perimeter. And then this is how we design your security. So within your security, you actually start shift left. So we've got shift left security, where you start devising your infrastructure using a simple development platform like that. So you have development, deployment, and runtime. And all those comes through Snyk. I don't know if anyone know about Snyk, yeah? So Snyk, OPA, which is open source. Again, they use a Rego behind the scene, which is a policy definition language. And then again, with webhooks, you can automate all that with GitHub Actions. So that just gives you an idea of how you can orchestrate all that stuff, right? So what is important in this? So the whole thing is governed by benchmark standards. Some of those standards are CIS controls, right? You got CIS version 8.1, which is most current now as well. Then, so we have regular. So if you're Sentinel guy, you can also use Sentinel, but again, it's restricted to AWS environment. But regular Sync and Sneak and Opera gives you a more elaborate policy definition across the board, right? So this is how we write the policy, right? Using, again, regular used to be part of Fugu. I don't know if you know that company, but Fugu being purchased by Sneak, right? So all that stuff changed. So we have actually to define a regular policy. So we have your regular policy defined. If in case of resources, you can say S3 bucket must be tagged, S3 bucket must have a server side, and S3 bucket must have private, must be defined as private. So you have all that stuff that is defined. And then here we also have exemptions to that rule. We've got what is called waiver the regu, where you can create exemptions to the rule. So in case where it becomes overbearing for you, you can actually exempt those as well. So again, this is how we set it up. You can see the rules comes up, you see the definition as well, and the result set. So this again gives you a little bit of rules that you can use with the CIS controls. If you look at here, CIS control version 1.4, and then you can have more than that as well if you want. So this is Fugu. I used regular initially, but because there is a transition from regular to Fugu Sneak now, so this is just a way to say, there is a transition about it. Again, if you want to go through this policy definition, you can also write yours in Sneak. And then if you want to use a SaaS application, again, you can use that SaaS. And it gives you similar. But again, if you do your stuff from CLI, I bet you get better result. Anyway, this is from experience. Supply chain. So in all of this as well, one of the breach areas, attack vectors, is your supply chain. Your image and all that stuff. So you need to be able to secure that within your environment. And what we've done with that is, in the case of containerization, we have what is called Kivano. Don't know if anyone have any experience with that or used it. So it's a policy definition for containerized environment. So your Kubernetes as well and all that stuff, you write your policy definition in the YAML file, and then you send it through your Kubernetes as a runtime definition, and it's be able to define your policies for you as well. And this is how it looks. So you have the Kivano.io API, view one, and then once you write it, again, in this case, it was just a simple privilege escalation. So you don't want two pods talking to each other. You want to have only fine-grained escalation within your environment, so you can write that definition that way. And then this is on the right-hand side, you just have a normal, the way you write your pods in the YAML file, but you would have written the policy definition ahead of time. So it's something very nice. These are all ways to do that stuff. And then finally, we have the last part of it is Meter. I don't know if anyone knows about Meter. Okay, so Meter is an advisory tactic. So it's an end-to-end definition of how a breach is assumed. So from start to finish, within your SDLC, you start using Meter to go through all the initial process. If I define something, is that a tactic that the breach can occur or happen? And then Meter provides for you all that framework. So it's actually a framework for breach and anomaly detection as well. So this is how it works. So pre-attack, before an attack happens, you would have assumed that attack, okay? It's just a mindset. All right, this is going to happen. Within the process of attack as well, you would have also assumed that there's going to be an attack. Can I mitigate that attack up until the breach and then post-breach? So Meter provides you a framework that you can use within and align within your infrastructure from end to end. And finally, this is how it looks. So within the structure of that design I showed you, we injected Meter with Security Hub and Guard Duty for AWS, and it provides you something similar to this. You can use a Lambda to be able to get a result with QuickSight and all that.